Well, it's a great honor for me to be receiving this prestigious award of Tucker-Hasegawa. I'm just so thrilled, and I'd like to express my sincere gratitude to the IR Award Committee members, and in fact, all the members of IR, because through the IAARC and ISARC, I have grown a lot to become who I am today. So thank you very much. The topic that I chose for today's speech is, as Fred said, smart safety assurance for temporary structures. This is based on a research project that I recently started. And some of my research team members contributed to the preparation of this material. So their names are here. So larger credit should be given to them. I'm going to first of all lay out some background of this research. Then I'm going to talk about some project content. And I will talk about the part that I am focusing on with my specific laboratory research members. Then some conclusions will be drawn. First of all, the background. The Korea is in trouble, I would say. South Korea had about $1.64 trillion of gross domestic product last year. But 1 year before that, it had larger amount of gross domestic product. And if you take a look at the chart on the right side, the economic growth rate of Korea has been less than the average world growth rate for the last 9 years. This situation is a bit strange to many Korean people because Koreans are used to high level of growth rate. At one point in time in 1970s, Korea had even 15% growth rate. So this situation worries many Korean people. The construction industry of Korea is not that different from the picture that I showed you in the previous slide. The value of domestic construction orders in South Korea has about 150 trillion won. 150 trillion won is roughly converted to $133 billion US dollars. But the problem is it is not growing. It is stagnant. If you take a look at the chart on the bottom, you will see a bit darker pictures of Korean construction industry. The value of overseas construction orders by South Korean builders reached the highest level about 10 years ago. About $70 billion of orders was obtained, but now it receded to about $30 billion. If I talk about the safety record of this industry of Korea, it's even worse. The death rate in industrial accident per 10,000 employees of the construction industry of Korea is 1.65. And this is way higher than those of other industries. When compared to other major OECD countries, Korea is ranked low. So, as I said, Korea is in trouble. This chart is made by one private consulting company, and they're saying that the construction industry is at the very bottom in terms of level of digitization and productivity growth. So now the government of South Korea is pressured to do something about this. So they try to change laws and regulations, and they try to infuse new ideas into this construction industry. And 2 years ago, they laid out what is referred to as the Smart Construction Technology Roadmap. And this is basically the plan by which they believe they can revitalize the construction industry of Korea. And Korea Agency for Infrastructure Technology Advancement, excuse me, abbreviated as KAIA, is actually the funding agency for construction research and development. They have produced many programs to boost the construction economy, construction industry of Korea. And the most recent one is the Smart Construction Technology Research and Development Program, which was launched this year in the last April. And this Smart Construction Program is now managed by the Korea Express Corporation. Korea Express Corporation is usually in charge of construction and operation of highway networks of Korea. So basically, the whole construction, the Smart Construction Program is geared toward designing, building, and operating good road infrastructure. This is about $180 million project, and it has 6 years of durations. And let me briefly talk about some major areas of this program. The first area is equipment. Automated control of construction equipment is being investigated in this first area. The second area is actual construction of road structures. So lots of prefabrication and modularization approaches are being investigated. And the third area is smart safety. So this is the field that my project belongs to. So we'll try to cover the issue of how best to be able to make sure that construction workers are safe. And the fourth area is digital platform, smart construction digital platform. So we are trying to emulate the success of the so-called platform industry in the construction industry. And all of these areas are going to be integrated and tested and validated in the Smart Construction Comprehensive Test Bed. So if we succeed in developing good technology, they're going to be marketed to the construction industry. That's the plan. Sorry about the scratch. Yeah, now it's gone. And this is the part that I'm focusing on, temporary resources and structures. Temporary resources, by that I mean those structural members such as pipes and H-beams that are going to be used for temporary structures such as excavation support systems or scaffoldings or concrete formworks. According to the statistics, 38% of all industrial casualties of Korea are caused by temporary structure-related accident. I'm ashamed to say that every year we lose 300 precious lives in Korea because of this temporary structure-related accident. And 69% of them is coming from the construction industry. So we are trying to do something about this. So this is the organization's chart of my research team. We have big sponsors, Ministry of Land, Infrastructure and Transport, and KAIA, Korea Agency for Infrastructure Technology Advancement. And as I said, Korea Express Corporation is the program manager. Under their supervision, I formed this excellent teams with 14 other agencies and companies and universities. And For example, Hyoungkwan University professors such as Professor Simseong-han, Kwon-Sunuk joined our team, and Ina University professors such as Professor Young-Seok Kim and Jeong-Yeol Kim, they joined our research team. And companies like Smart Insight, Deep Inspection, and ATMEX are also our research members. And government-supported institutions such as Korea Scaffolding Institutions are also our research members. And Korea Temporary Equipment Association is also research member of our team. And researchers at the University of Dayton are also involved in this research. What is nice about this formation of team is we have participating companies and testbed. So these participating companies are the future users of the technology that we will be developing in this effort. And those technologies will be tested in those testbeds provided by our partners such as Incheon Metropolitan City. So I think this team is well formed. So this project, Smart Safety Assurance for Temporary Structures, has two major technological areas, Technology 1 and Technology 2. Technology 1 is to make sure that our temporary resources, those structural members, are quality controlled. And Technology 2 is to make sure that temporary structures, when they are built, when they are dismantled, and when they are in operation, their structural integrity and safeties are monitored. That's how this project is composed of. So let me delve into a little bit more details of this project. Under the first technology area, we have this research component of damage quantifications. So we are trying to use structural from motion type sensing and magnetic flux leakage type sensing to understand the quality of temporary resources. Structural from motion sensing is used to check the shape integrity, and magnetic flux leakage sensing is used to check whether or not these materials have some cracks. And their sensing result will be integrated and visualized so that we can have some informed decisions regarding the quality of those structural members. Hyoungkwan University professors are behind this task, and they have lots of experiences in various construction automation areas. For example, they have worked on AI and IoT-based cable tension estimation technology. Those of you who have done some work in the cable-stayed bridge construction, you would know how difficult it is to control the tension of these cables manually. But these process has been automated by our researchers. And Smart Insight is a company who is involved with our research effort, and they have experiences in applying this magnetic flux leakage sensing to civil engineering structures, such as this bridge construction project. And this company called Deep Inspection has expertise in deep learning-based image processing to detect various kinds of distresses on the surface of civil engineering structures, such as tunnels. And this slide shows you the second part of the first major technology area. This is to develop performance evaluation criteria for temporary resources and temporary structural member. We have 9 structural members that we are planning to investigate. In fact, what surprised us right after we started this project is that only 3 of those structural members have clear, quantifiable evaluation criteria. The remaining 6 of them do not have any quantifiable evaluation criteria for their quality check. I don't think this is the only problem of Korea. I think this problem is shared by many parts of the world. So we'll try to develop some standardized process and quantifiable evaluation criteria to control the quality of structural members for temporary structure. Korea Scaffolding Institution is behind this task, and they are actually authorized by the government to test and certify temporary resources for their quality check. So they have lots of expertise in this area. Ina University professors are also behind this task, and they have lots of experiences in these types of automation effort, intelligent excavation system, automated equipment control system, crack sealing robot, and exterior wall painting robot. This is the first part of the second major technology area. And we are trying to use image-based sensing and laser sensing to understand the installation and dismantling process of those temporary structures. So we'll try to use those sensing to identify any hazardous element of these temporary structure. And actually this particular task is taken care of by myself with my research team members. And I have done some work in this area of, for example, facility management using AR and deep learning. And I have used this augmented reality to instantly alarm the construction workers on the side of any imminent dangers, such as this approaching truck. And I have done some work using UAV and deep learning to understand the productivity of the construction site and safety record, safety status of the construction site. And this slide shows you the second part of the second major technology area. Basically, we are trying to use IoT, Internet of Things types of sensors to monitor the operation phase of the temporary structures. So all kinds of different sensors like tilting sensors and pressure sensors and strain gauges, and they are wirelessly connected so that we can understand the status of these temporary structures. And Yonsei University Professor Lee Jun-han is working on this issue of monitoring underground structures, such as this foundation, pile foundation structure, using smart sensors. And a company called ATMX has lots of expertise in low power and long distance wireless communication measurement system. So they have done works for checking slope stability using these types of sensors and networking system. And they have done some work for checking the stability and structural integrity of bridges. And urban environment was also monitored by their technologies. We have very clear and concrete scenarios for the field application of our research result. For example, we have investigated the life cycle of temporary resources, how they are produced, how they are delivered to the site, and how they are used and recycled. At every important step of this life cycle, we're going to use those aforementioned sensing technologies such as magnetic flux leakage sensing and structure from motion sensing based on explainable AI, artificial intelligence. This explainable part is very important because our result has to be something that everybody can agree to. If it is not explainable, then people would have a hard time in making some consensus about the quality of temporary structure. So this is our plan for technology 1. in case of technology 1, in technology 2, as I said, we're going to use imaging sensing and laser sensing and all types of IoT sensing. And these sensors will be optimized such that they can measure important characteristics of the site. And these information will be transferred wirelessly to the central server. And on a real-time basis, these data will be analyzed so that finally, eventually, event-driven risk notification will be possible. So based on this result, we're going to be able to dispatch some important safety-related information to the construction workers or anybody who is in charge of the construction site. If I may add a little bit more to what I have done and what I'm going to be doing, I have been testing smart mobility for data acquisition. By smart mobility, I mean robotic dog and unmanned aerial vehicle, UAV. And these smart mobility will give extra ability to our sensors, such as laser sensors and imaging sensor. And we have implemented this handheld mobile laser SLAM equipment based on state-of-the-art SLAM algorithms, such as LeoSAM. And we have gathered some point cloud data of these temporary structures. So we're going to use these different types of smart mobility, such as robotic dog and handheld device and UAV, to gather the point cloud data. And these point cloud data will be used as this feeding information for our deep learning model that we're going to be developing. And hopefully, this effort will lead to automated classification of point cloud data such that we can accurately identify some hazardous area for our construction workers. These are the pictures that I took when I visited a Korean construction site a couple of months ago. This is hotel construction project. This is about $50 million project. So to my standard, this is not that big. However, the scenes that I'm looking at is quite complex enough. So I envision my future technology system to be deployed on this site to scan the whole construction site and accurately identify any hazardous element with regard to temporary structures. That's going to be challenging. And it's a challenging issue. So I'm going to have to lose some sleep. But this is not the only challenge that we are facing now. There is much more grave challenge. And this challenge is already with us, COVID-19. Every day, we hear the report from the government with regard to how many people got infected and how many people died of this virus. I do not know how long it will take for us to overcome this pandemic situation. Some people say it will take 1 year, or some people say it is going to be forever. So we have to have this weird format of online presentation for foreseeable future. But what seems to be certain out of this tragic situation is that this has actually accelerated the arrival of a future. We are living in now in year 2023. Maybe we are living year 2025. The future is already here. This slide shows you some examples of the efforts of Korean contractors and some owner companies. They became much more serious about adopting new automation and robotics technology. I think maybe the momentum is here. Maybe the atmosphere is right. maybe the mood is right so that we can finally have our great technology to be fully deployed on many parts of the world and many construction sites so that we can improve our productivity significantly, and we can improve our safety very, very much, and we can finally accelerate the so-called digitalization of the construction industry. However, I cannot do this all by myself. Of course, I need your help and I need your guidance. And because of that, let me open the floor for any question or comment. Thank you very much.
Thank you very much, Hyoungkwan. Thanks a lot for this presentation. That's a very, very large project. There's quite a lot of people involved and a lot of activity. I like the integration of all these things together. I think that's quite exciting. I do have a question already from the floor. If people have another question, please type it in. I think it relates to a comment I was going to make myself. I'll read to you. So it says, tracking temporary resources over its life cycle is very interesting from a circular economy perspective. Question, for a scaffold to be bad, it may take years. Do you accelerate the aging of such material? And I think I was going to complement this. You are planning to use machine learning applied to reality capture data, most likely 3D point cloud, but maybe imagery as well. Have you already, I mean, how do you plan to essentially build that data set? Because as the question suggests, you will need to get data about scaffolds that are correct, but also data about scaffolds that are not correct. Yes, I'll be curious about this, and maybe if there is any intention to build some sort of open database of labeled imagery, because a big issue for all of us is getting these data sets, and I think there is a need for a collaborative international effort to do that.
Thank you for your questions. This is a great question. Actually, this is the kind of question that somebody who knows from the inside about the process of everything in this particular matter. Yes, actually, we are planning to build some database after accumulating a certain amount of data, and we will be very much welcoming any collaboration offer from any foreign partners, because as I said before, this problem doesn't apply to Korea alone. I think this problem is shared by many parts of the world. And in fact, we're going to use, as I said, the structure from motion type sensing and magnetic flux Nixie type sensing. And those sensing results will be integrated and visualized. And when we see some defective temporary material, there are two ways of deal with this problem. One is fix it. The other is get rid of it. So if that temporary resources are too old and too worn out, so it cannot be repaired anymore, then we have to throw it away. And actually, that's the industry practice as for now. But we're gonna actually refine the process by using more data with more, as Fred said, machine learning type of mechanism so that we can, have better results. Did I answer your question, Frederick?
Yes, more or less. I mean, I'd be curious to, one of the questions I was going to ask is, how long is the project and where are you along the line of this? Is it just starting now? And therefore, maybe, we will know better how far you're getting and what kind of database you're building. Because I think many people around the world might be looking in that problem and building their own little data set, and everybody build their data set. And in the end, we would all benefit if we just build up those data sets collectively.
Thank you for your question. In fact, this project was started from the last April, so it has been around maybe 6 months. And it has 6 years of duration, the whole program. However, the government is actually urging us to get the job done as quickly as possible so that we can bring this technology to the market as soon as possible. So for the first 2 or 3 years, we'll try to develop the technology. Then the later part of this project will be probably testing and validating phase. So early on, we're going to do lots of work to develop actual technology. So I think the chance of cooperation or collaboration with some foreign partners would be quite possible.
Okay. I do have another question, Johan. I hope it's okay if I take that last question, maybe. This is from Sudara Rahman. Could you please share your thoughts and experience on the ease of adaptation of the latest technologies by the on-site workforce? The initiatives, and maybe about the initiatives to ease that adaptation. So, for example, I guess, for example, the use of AR or the dog or something like that, how, you know, is the workforce responsive to this? Or is it difficult or challenging to integrate that, especially, for example, from the point of view of Korea or South Korea, sorry.
Very good question. Thank you very much. Well, what surprised me for the last 18 years of professor experience is that if I give a little bit of vision to my student and they achieve it. So if I set a goal in the very beginning of a semester that this is something that you have to do, then they just get the job done. So those latest technologies, now they are uploaded to, for example, GitHub, right? The source code is shared. And actually this comment is relation to one of the things that I wanted to suggest. Data sharing, not just data sharing, also code sharing, source code sharing. If this kind of culture is nurtured in our society, then maybe we can have more easy adaptation of these so-called latest technology. That's how I address this question.
I think the question was more about on-site workforce, so construction workers, and, you know, do they engage with these technologies? Do they welcome the technologies? What is their, or do you have to do a lot of work? This question is actually related to one of, I was thinking about it, which is the issue of human factors. So, you know, in terms of safety, the impact of this involves human, and their behavior is very important. So,
very good question.
Yeah.
Yeah. When I took a course, construction automation, back in 1998, by Dr. Carl Haas, my PhD supervisor, and he told me that it's very important to understand labor reactions to construction automation technology. Yeah, I'm feeling that labor reactions every day. I try to do something with this new technology. And that's why I engaged with the existing stakeholders of this process from the very beginning. For example, I describe those participating companies in my research form, in my team formation. Actually, they're the ones who are doing the actual work for productions and delivery of this temporary structure members to the site and recycling. So we are already engaging with them when it comes to developing this new methodology. We get their feedback and we provide something to them. So we try to have some harmony with them. So that's actually quite important aspect of our effort of implementing new idea in the field. Good question. Thank you.
Okay, thank you very much.